Okay, today we're going to learn about electron configurations. So it might be a little difficult at the beginning just because it has a lot of new vocabulary in it, but bear with it. We'll get through it, and then we'll do some examples at the end, and you'll see that it's actually pretty easy as you pick up the patterns. So orbital notations, that was what we're going to start with. So they are basically lines that are used to represent the orbitals where electrons can be found. So we know that there's 3 subatomic particles: protons, electrons, and neutrons. This is going to be all about the electrons and where we find them and how we describe them when we talk about them on paper. So lines are labeled with the energy level and the shape, or basically your subshell. So some examples are, like you've already been working on your electron configuration periodic table and stuff. So you've got your energy level at the beginning, okay? And then you've got how many electrons are being found there, okay? Those are your examples of that. So you are going to draw some of them with arrows. Arrows are used to represent basically the different spin that you will have with the electrons. Because in order for them to occur, they have to be spinning in opposite directions. So there's 3 rules that we're going to have to learn about that. So you'll have to have them looking like this. You can either do a full arrow up and down, or you can even do a half arrow, which is probably what I'll be doing, so just so you can be aware. Either one, but it just represents that the electrons are spinning in 2 different directions. There are rules for these electron configurations. There's the Aufbau principle, the Hund's rule, and the Pauli exclusion principle. So these 3 things will help you identify what can be written, what can't, and how we write them down basically on these electrons. So on your Aufbau principle, each electron basically occupies the lowest energy level. So this is the one that's closest to your nucleus, and it works its way out, okay? So when you're looking at your chart, your lowest energy levels are here because it only holds 2 electrons, and then it kind of goes out and works all the way over to 8, okay? I know that probably doesn't make sense yet, but we'll get there. So 1s is this first block. So you're going across that paper. This is the first block, okay? Second block is right here, ends, end of the block. Next one, next part of the block, which is your P block, end of it, okay? So that's what it's kind of talking about. On Hund's rule, it says orbitals of equal energy will each hold only 1 electron before they will hold 2. So if I give you an example of 3p4, okay, you'll see that when we talk about figuring out how to write that, okay, you have to kind of give me the roadmap to it. So 3p4 is all the way over here, okay? So when we fill this box in, you can only tell me the amount of electrons that are in it. So we would have to go from a 1s2, because that's the end of 1 block, 2s2, end of that block, and then 3p4. So when we write in the electrons for the arrows for this part, just for the 3, you have to go 1, 2, 3, and then 4. That's just talking about your P part, okay? Because we can't add a double one until all 3 parts of the orbitals are filled. So once I had a single one in it, then I can go back and start doubling it up. Okay? That's for your P block right there. So your Pauli exclusion principle. Electrons that share the same orbital must have different spins. So like I said earlier, they have to be going in the opposite direction. So that's why we have an arrow going one direction and one going the other way. So they're going in opposite directions. Okay, so we're going to look at specific examples. Okay, so it says practicing with orbital notations. So you need to have your handy chart with you, okay? So we look at hydrogen. Hydrogen is atomic number 1, okay? It's your electron configuration is 1s1. So you're going to put a 1 right there. So this tells me that there's only one electron, okay, in its orbit right there. If we look at helium, you look at your chart, and it's 1s2. So we put a 2 here. This superscript right here tells me that there is 2 electrons in that problem, or in that element, okay? So lithium, we look at lithium, and we see that it's at 2s1. So we see that's right there. But we have to make sure we tell how we got there. So the first energy level is 1s2 because that's the end of the block, okay? I know it's kind of confusing. I'll explain that here in a second. So this tells me I've got 2 electrons, and I've only got 1 right here. So that accounts for all 3 electrons that are found in lithium. So then you go to carbon. So you have to look at your periodic table, and you see that carbon is number 6, okay, atomic number 6. So we have to account for how we got there, or from what is energy level. So 1s2, okay, 2s2 is right here. And then we've got 2p's. There's 3 orbitals for it. So all of these will add up to 2p6, okay? Well, we don't need all 6 because we don't have that many electrons because we are stopping at number 6 right here. So that tells me it's 2p2. So I don't need all of those. I just need a 2 right there, 2p2. So 1 up, 1 down, 1 up, 1 down because they're spinning in opposite ways. Then I look at my p's. I only have 2. I cannot put them both in this area because my rule tells me that I have to fill each orbital, okay, each level first with a single one before I can start doubling it up. So 1, 2, okay? The other one's going to stay empty, and these don't have pairs next to it because basically carbon doesn't have enough electrons to do that, okay? So flip over. Now we start getting to some longer ones. So we've got chlorine on the back. And you'll see that chlorine is what number? Go ahead and find it on your periodic table. You'll see that it is 17. Okay? So what do we do with that? We basically look at your big chart that you've drawn today. Okay? So it's basically a street address. So let me kind of explain. So this is the first block. If you're giving me directions when I leave school, okay? You leave school, you make a right onto Stonebrook Parkway. Then you go down to Legacy and you make a right. And then you're going to drive down to 423 and then you're going to make a left. Okay, you've got to tell me every time you're at the end of a street or where you want me to turn, that's when you've got to tell me the directions. So basically what the electron configuration is, I'm at the end of the street or I want to go to the next energy level. So I'm going to tell you the last place right before I change my direction or go to a new place. So 1s2 is the end of that block. So I have to account for him. So that's why I'm going to say 1s2. Then I'm going to go to this next block. 2s2 is the end of it. So I account for it. Okay? I don't have to write 2s1 because that's just me driving down the street or me going on that energy level for this electron. I didn't get to the next energy level until I was done here. So I'm done there. So I go and keep going. So I account for all of these. Now we're going for chlorine, which is 17. So we're going to go all the way past this whole block. So I have to write the very last thing because I needed directions that I'm going to go to the next orbital or the next energy level. So 2p6. So these count together. So 2p6. Okay. We jump down. End of this block is 3s2. We're going past that, so we have to account for that. So that means I'm going to the next part of that energy level. So then I jump over here. So this is the new part. I don't care where you start. I care where you end. So we're going to chlorine, which was number 17. It's 3p5. So here I will have 3p5. Okay? So now all we have to do is draw in our wonderful arrows. Okay? This one tells me I've got 2 electrons. This one has 2 electrons. This one has 6. So 1, 2, 3, 4, 5, 6. Remember, we have to fill all 3 of them up before we can start doubling up. Here's another one that has 2, because we look at your superscript. Now my superscript here tells me I have 5. So 1, 2, 3, 4, 5. There's still room for one more electron, and that's okay, because if I had one more, then we would be argon, and we're not. We're chlorine, so we stop because it has 17 total electrons. So you can do that for every single element on the periodic table. So when we start looking at iron, iron is what number on your periodic table? It's number 26. Okay, so there's 26 electrons in iron. So we do the same thing. It's the same roadmap. You're going to see the same patterns. So where did we start? Going across. We passed this block. We stopped there. So 1s2. Okay, done with that one. Moving to the next one. 2s2, end of that block. Next one. Going across the whole thing. So this whole piece right here is 2p6. Next part. 3s2. Okay? Let's make sure you guys can see that. So I'm going to write 3s2. Then we're going across. We make it through that whole block over there. So this one is 3p6 now. Okay? So then we come back across, go to the next layer down. It's kind of like reading a book. You're just reading across all the way down. So we're going to go across the 4s2 block, because that was the last part in that block. Then we hit the D block. Now this is where it changes. This is where I hope you guys caught it earlier. It goes from 4 down to 3, and that has to do with these not being balanced electrons, and they kind of drop down at an energy level. Okay? This is where you have to memorize it and be sure you don't make a mistake. So this part, D block, there are 5 of them. So this is 3D, and then we have to figure out which one was iron. So iron was number 26, so go to 26 and it's 3D6. So you write 3D6 on there. Okay? So we're done with this paper. We can kind of stick it to the side right now. So we have to go and fill this in. So 1s2. Draw all your electrons. Okay? This one has 6. 1, 2, 3, 4, 5, 6. This one has 2. Make sure your arrows are going in the opposite way. If you don't, then they're wrong. Okay? Because that's one of our rules. So you've got 2 there. Now you've got 6 in your d orbital. So remember, you have to fill in each box or orbital part first. So 1, 2, 3, 4, 5. Now I can double it up. That's 6. Okay? Does that make sense? If not, it'll come along. It's okay. We'll get there. So those are your electron pieces when we do orbital notations. Okay? Those are the little flags. Those aren't detrimental to know, but you need to know them for your quiz and your skill check you'll have. For the next part, we're going to focus on electron configuration notation. So this is what we've already been kind of doing with the numbers right here. So all the same rules apply. Yay, no new rules. So you get rid of basically your lines and arrows. So it kind of simplifies without having to draw all those big boxes. Okay? So now we're going to use our superscripts. Superscripts are those little numbers that are flying high above the number right there, kind of like Superman. Okay? They represent the number of electrons in the orbital. So when I talk about 2p2, this 2 right here tells you how many electrons. Okay, that's your superscript. So all your superscripts would add up, and they'd basically equal your atomic number. So that's what this box is telling you. That your sum of the superscripts should equal the atomic number. Okay? So remember, our atoms are basically neutral because we have protons and electrons. That's what you saw in that was one of your CBA questions. Those protons are positive, electrons are negative. They cancel each other out, so they're neutral. So this all basically gets arranged by their energy level. So when we start practicing with hydrogen, okay, when you saw it on your chart, the very first one over here, it is 1s1. That's all you have to write, 1s1. Okay? So then you start looking at, our next one is helium. It's 1s2. It's in the same block, so I don't even have to write that first one, okay? So then 2s1, okay? We didn't have to go any further because helium was there. We stopped. So lithium, though, we go through that whole first block. So we have to account for that. 1s2, we write the end of that block, and then we have to write where we're stopping. Kind of like stop at this house. This address. So 2s1. That's lithium. Okay? So on carbon, we look at what number it is. It's number 6 on your periodic table. So we got to get all the way over here. So start at the beginning again. The end of the block, I write it down. 1s2. Go to the next block. 2s2. Go to the next part. And we're stopping at number 6, right, for carbon. So it's 2p2. Alright. So then we're moving on to chlorine. Okay? So chlorine is what number? We said it was 17, right? So there should be 17 electrons when we add this up. So same thing. Look at your map right now, okay? Your table. End of the block, 1s2. End of this block, 2s2. Keep going. 2p6 because we're going to get to pass that part. Okay? And then we are moving on to 3s2. We're going to pass that block. Going to the next one, and it's going to end at 3p5 because we're all the way right here. So if I add all these superscripts up, 2 plus 2 is 4, plus 6 is 10, 11, 12, plus 5 is 17. We know that we did it right, okay, because there's 17 electrons in chlorine. Okay, so go ahead and try to do iron for a minute. I'll give you a minute to work on that. Remember, you're writing the end of every block that you pass until you get to where you need to finish. So if we look at iron right now, there is 26 electrons because it's number 26, atomic number 26. So you're just starting at the top, working your way across. Every time, 1s2, 2s2, 2p6, 3s2, 3p6, because we're going all the way across. And we keep going. We're not done. Okay? 4s2. And then here's where the tricky part is, because that D block comes in. 3, we go down that energy level. 3D what? What are we getting to? So we need to get to 26, so 3D6. So go ahead and take a moment to add all of those superscripts up. And you should have 26. And so we would know we're right. Okay? Comes with practice. The more you do it, the easier it gets. It is just the same pattern over and over because you're using the same chart. This is a cheat sheet right now. You are not going to get to use that forever. You're going to actually have to do it straight off your periodic table. So you're going to have to know that this is 1s1. This is 1s2 over here as helium. Okay? So what will help you know that is these numbers over here. Okay? All your period numbers. So this row is 1. This is 2. So it's 2 s's. 2s1, 2s2. Over here, this is still 2, but now it's the P block. Okay? So you're going to have to memorize the patterns. These are the S's right here. This is your D block. This is the one where it changes and it goes down 1 energy level. So instead of it being 4, this will change down to 3. So that'll affect every D block in here. So as long as you can kind of start memorizing and looking at that pattern, you'll be fine. It'll take time. It's okay. We get a couple days with this. Alright, next part. So that's a lot of stuff to write when we do electron configurations. There is something that's called a shortcut. It's called a noble gas shortcut. So if you remember, your noble gases can be found in group 18. Okay? So that is the whole last group over here. So these are our shortcuts, and so you're going to love them. If we do write a shortcut, it is going to be with a bracket, okay? So instead of starting from 1s, that first block, we actually get to go ahead and skip it and go down to your noble gas. Okay? And we get to put these brackets around it. If there's no brackets, it's going to be wrong, so make sure you put those brackets on there. So the very first one is chlorine. So if we look up here with what we already wrote up here, okay, that was pretty long. So let's go ahead and look on your periodic chart, and you're going to look before chlorine. You're going to have to go backwards, or you're going to have to figure out what noble gas was before it. Not the one next to it, not the one after it, the one before it, and it's neon, okay? So we're going to take that neon, and we're going to put it in brackets. So then all I have to do is write anything that comes after neon, okay? So when you were looking at this, actually let's use your other chart, it'll probably make a little more sense to you. So neon's at number 10. I know I have to account for this block right here, so I'm going to write 3s2. Then we got to keep going because we are actually getting to chlorine. Chlorine is number 17, so then 3p5. Okay? So now we're done. That's the shortcut for chlorine. You can see the difference between the two. Okay? One's got a lot less writing. So it's basically that shortcut, noble gas, with the stuff that comes after it, to be more specific. So iron was really long. Okay? We had to write all the way across. So we look at iron. You look at your periodic table, figure out where iron's at. Okay? It's in the center in your transition metals. You look backwards and you see that the noble gas that comes before it is argon. Okay? So you're going to take that argon and put it in a bracket. Remember, one capital letter and a small letter. Do not capitalize both of them. It means something different. So then I got to write down what's after that. So if you're looking at your chart, okay, we are trying to get to iron. So everything that's after argon would be 4s2 and then 3d6. Okay? Because it is number 26 for iron. So then here's this big guy right here, strontium, Sr. Find it on your periodic table first. It's number 38. Okay? So we look back and we say, what's the noble gas that's right before it? You're going to see that it is krypton. Okay? So you're going to take that Kr, put it in brackets. Okay? And then you got to write anything that comes after it. So we know that krypton only has this part after it, this block, that 5 block. So and it ends on 5s2. So all we have to do is write 5s2 and that one's done. We don't have to write all that extra pieces to it for each level that it changed because it's got that noble gas in it. Okay? So for the rest of class, you guys are going to be working on your homework. Okay? So you should have some individual practice right here. So these things all these questions you should be able to get out of your notes. Okay? I'm going to go over 5 and 6 really quick with you. And then you should be able to do all the rest. Front and back should be done. On number 9, make sure you tell me the rule that is being broken, if there is a rule being broken, and what's wrong with it, basically. Okay? And on number 10, you have to tell me the whole electron configuration, not the shortcut. Okay, just throwing that out there. Alright, so let's go back to number 5 and 6 really quick. It says how many orbitals are in each of the following sublevels. So when we look at S, we have one box, basically. Okay, one orbital to fill. And then it says how many electrons can it hold in that sublevel. It can hold 2 in that. Because there's only one box, it can only have 2 electrons. So when you go to the P, remember that these are kind of conjoined together. So there are 3 of them, 3 boxes right there. So there's 3 sublevels or orbitals. It can hold 6 electrons because each one can hold 2 each. Okay? When you look at D, there's an example down here. There's 1, 2, 3, 4, 5. So that's all together. So there are 5 orbitals for D, and it can hold 10 electrons because we basically are doubling it. Do you see the pattern? Okay? If you couldn't figure this out, all you'd have to do is kind of look at your chart and go, hey, the f orbital holds 14 electrons. It maxes out at 14. So we could put 14 here. Well, we know that has to have half of that for your orbital, so there's 7 orbitals for the s, and it can hold 14 electrons. Okay? So that should help you out. It should get you started and going. Just remember to refer back to your rules about putting orbitals, like making sure you line them up one by one before you start doubling them. Okay? That's the biggest part on that. And that you're doing the arrows in 2 different directions. Okay? Because it does have a different spin on those electrons. Teacher should be walking around helping you if he can. If you have a problem, just wait till class or come to tutorials, and I'd be more than happy to help you. Okay? Thank you.